Hello students, today in this video we are going to study about law of flotation. Flotation is about when a body is placed in a liquid, whether it will be able to stay up or it will go down. If it goes down, you call it sinking, and if it floats, that is floating, right? And what is the law? How are we going to determine a body will sink or float? Yesterday we discussed about Archimedes' principle. In Archimedes' principle, what we said? When a body is wholly or partially immersed in a liquid, it experiences an upthrust, wholly or partially. It experiences an upthrust, and that upthrust is equal to the weight of the liquid which is being displaced. And this is what we called it as Archimedes' principle, and I derived an equation for you. Now, extension of that, the same thing, we are going to create this idea of law of flotation. You may sometimes see a large ship which is so heavy is able to float in water. But you take a small pin and you place it on the surface of water and it will sink. Now, why does it happen? What is the reason for that? So, this is what we are going to discuss in this particular video. Now, yesterday I asked you a question. For example, I said that there is a spring balance, okay, and I tie a stone to this spring balance, and I said that the actual weight of the body, you call it as a W, that is equal to 100 gram. Okay, gram weight it becomes, you can write it as gram weight, GWT. Now, when I immerse it in water, okay, what will be the reading in the spring balance? And if it will be less or it will be more, you should know that it will be less. Why it will be less? It will be 90 gram weight. The weight has reduced. Mass has not changed. The stone is remaining same, but only the weight is decreased, and that is called apparent weight. This is referred to as apparent weight. You can call it as W dash. Now, why there is a difference? Because the stone is being pushed upward by the upthrust of the water, and the upthrust is equal to, the upthrust will be equal to, you can call it as U, that is equal to 10 gram weight. Okay, so that is why due to the upthrust, the weight appears to be less, and that is why it is apparent weight. Once you take it out, again in air, it will have the same 100 gram weight. So now we are going to connect these factors together, how this actual weight and all these are added together. Fine. So I will write a formula here. Actual weight. Okay. Instead of actual weight, we will talk about apparent weight. Apparent weight is equal to actual weight minus upthrust. Okay. So this is a formula which we are going to use now. This is what we found now. Apparent weight is W dash O. Okay, that is equal to actual weight is W, upthrust is U. You remember, we can write the weight as V rho G. V rho G. I am going to make a small change now. I am going to tell you what it is. Minus V rho G. Yesterday which we did, rho. How is it possible? Now, I am going to make a change and I am going to explain it to you. Let us take the water. The density of water is equal to rho. First we have taken. Now I take the body and I immerse it. Right? And the density of the body I have taken, the density of the stone or whatever the object I taken is sigma. So weight of the body will be V sigma G. because I have to take the density of the object which I have taken, and which is giving upthrust actually. Water is giving. What is the density of water? Rho. So density of object which we have taken is equal to sigma. So this is what I have applied now. Now what I am doing is, for simplicity, right, I take V sigma G outside and I write 1 minus, right, Vg is come, right, rho is there, rho, but sigma is additionally taken out, so divide by sigma. So this will be the formula. I can write another word, W dash is equal to, what is V sigma G? That is nothing but weight of the object. W of 1 minus rho upon sigma. So this is the formula which you can use it to solve numericals. Okay, so it's very simple discussion, right? Apparent weight is equal to actual weight minus upthrust. Done. Now W dash is the symbol and weight is W minus U upthrust. So V sigma is density of the object which is immersed inside, and the upthrust is by the rho, that is that of the water or the liquid. So I have taken V sigma G outside. Vg is common, so no problem. Sigma is additionally taken out, so I divide that rho by sigma. And the V rho G is nothing but weight of the body, so I write it W dash is equal to W into 1 minus rho upon sigma. So this is the formula. Now from here we go further, right? So keep this formula in mind. Apparent weight W dash is equal to W of 1 minus rho upon sigma. This formula we will use it for doing numericals and all the other discussions. Okay. So the next discussion is, I am taking a beaker and I am going to fill it with water. You know the density of water, I am taking it as rho. I am taking a stone. Okay, stone is heavier and you know very well it will sink. Okay, the stone is going to sink. That is sigma is the density of that stone. Now we have to study about why does it sink? What is the reason for it that it has sunk here? That is one thing. So suppose we take it. Another, you take for example a cork or a wooden piece, you take a wooden piece, right? And again we place it in a beaker and take water in this. Okay, and again rho is the density and a wood will float. Wood will float. Okay, so why is it floating? This we have to now study. So we have two formulas. That means, what is the law of flotation? Your body will float when the weight of the body is less than that of the weight of the liquid displaced. That means the amount of liquid displaced should be more than the weight of the body. That means weight of the body is less. In that case, the body will float. Suppose either it should be equal or it should be less. Okay, equal to or less. How can I do that part of it, which I am going to tell you now? Okay. See, weight of the body is greater than upthrust. Okay, just a minute. Weight of the body is greater than upthrust. What is the formula for weight? V sigma G is greater than V rho G. That is Vg goes, sigma is greater than rho. If the density of the object is more than the density of the liquid, and then the body will sink. The body will sink. Very simple. Density of the object is more, stone is more. Naturally, it will sink. Right? Water is less. So naturally it will sink. Now in the case of wood, okay, Now in the case of wood, W is less than U. Let us put this condition. That is, the weight of the body is less than the upthrust. Okay, that is V sigma G is less than V rho G. Vg gets cancelled, sigma is less than rho. So this is the condition. Or see, sigma is less than rho, or rho is greater than sigma. In either way it is one and the same. Rho, density of water is more than density of wood. I'll give you a simple example. Density of water is 1 gram per cubic centimeter. Density of wood is around 0.8 gram per cubic centimeter. So what will happen? This wood will be given an upthrust and it will be floating. In this case, you can say this is again 1 gram per cubic centimeter, and that of the stone or any metal and all you take, it will be around 2.5, something like that, gram per cubic centimeter. So naturally 2.5 is greater than 1, 0.8 is less than 1, and the body will float. You understand? This is, one is it can sink or it can float. There is another case is also there, and let me erase these two parts now, right? Yes. See, if suppose I take a case W is equal to upthrust, that means V sigma G is equal to V rho G. Vg gets cancelled. Sigma is equal to rho. That means the density of the liquid is equal to density of the solid. Then what will happen? Then the body will just float. We use the word, just to float. I'll show you how the just to float case will be. Water is here, okay, and it will just to float. It will not be up and it will not be going down, totally sinking, and this is called just floating or just floats. Okay, for example, in the summer season, you have cool drink and you have a glass of cool drink, right? And you put a piece of ice. Ice will float, okay? Ice will float. Why? Because the density of ice is less than water. And if it is more, then it will go down. That's a different case. That's stone or some other thing, right? In this case, just to float, it will be just floating, just below the level surface, just touching the level of the water. And this is the case where sigma and rho, both of them are same. It will look to you as if the object is not there. That means both of them are having same density. So it's nothing but, if it is water, it's also water. You can imagine like that. It will be just invisible to you sometime, that you can check it. Right. Now, after having done all this discussion, I would like to do one final discussion on the same thing, right? Taking it up, just a second please. Yeah. Yes. So what is that actually? Yeah. Let me just take my notes and write the heading of the thing. Fraction of volume submerged. See, I have made my own notes. I write it my own notes like this, and I prepare, right? And then from this preparation, I am able to teach you, right? Then it becomes effective while teaching. I will state law of flotation. It states that a body will float in a liquid with the weight of the liquid displaced by the immersed part of the body. Weight of the liquid displaced by the immersed part, right? So this is the liquid and this is the immersed part, right? The shaded part. If this is equal to, the weight of the shaded part is equal to weight of the liquid displaced, the water has been displaced here, right? Then the body, or greater than that, then the body will float. For flotation, that is the condition. Because this should be less and this should be more,